Now there are total 6 steps involved in a hypothesis testing. These 6 steps are common irrespective of any type of the test. So chi-square test is applied when we have two categorical variables for a single population. For example, in an election survey, voters can be classified as per the gender. And then they can further be classified based on their voting preferences. So in this case, we can use chi-square test for testing if gender and voting preferences are independent of each other or not. So let's see what are the steps involved in chi-square testing. The first step is to create a contingency table of the observed data. Now the table shown here is called contingency table. Contingency table displays the relationship between several categorical variables. We can see here we have information such as how many men and women have voted, how many votes have been given to candidate A and candidate B, etc. So this is called as contingency table. Then the next step is to find the expected count. So expected count is given as row total multiplied by column total and divided by total sample size. Now once we have calculated the expected count, we will create a new table using the expected count. After that, we will use the chi-square statistic x square. We will use this statistic to check if the observed data differs from the expected count. The formula for chi-square statistic is shown here. Here Oij is the observed value of two categorical variables and Eij is the expected value of two categorical variables. Now again I am restating, you don't have to worry and remember these formulas. The only important thing is that you understand the concept behind it. All these calculations will be done by our software, so you don't have to worry about the formulas. Now there is a small note given here. It says, in general, if 20% of expected count is less than 5, then chi-square test is to be avoided. So that is how you perform chi-square testing. Now let's move on to the last category, that is Anova testing. So Anova Test stands for Analysis of Variance Test. Just like the t-test that we saw earlier, Anova Test can also compare means. But the advantage with Anova Test is that it can compare means of more than two groups. Now we could also use t-test for multiple groups, but that is not a feasible choice. And it also increases the chance of error, as every time we do a t-test, we will commit some amount of type 1 error. And it will add up if we repeat that process for multiple groups. So that is the reason it is preferred to use Anova Test. Now let's see where we can use Anova testing. Suppose you have a group of athletes and we have divided them into three groups: amateur, mid-level and professionals. Now we want to measure their strength levels. So in this case, we can use Anova testing. The strength level is our dependent variable and our independent variable is the type of athlete. So as you can see here, we have three groups: amateur, mid-level and professional level. So instead of using t-test for multiple groups, it's better to use Anova here. So in Anova test, we will have to calculate the F statistic instead of the T statistic. And we will always do it using the software. Then after calculating the F statistic, rest of the steps remain the same as shown here on the top of the screen. Now here in the table, I have shown the steps that are required to calculate the F statistic. Obviously, you don't have to remember this because all of this will be done by the software. But just have a look at it and then we'll move on. So first we calculate the sum of squares. Now there are two types of sum of squares: between the group and within the group. Formula for both the sum of squares is shown here. Then in the next step, we'll calculate the degree of freedom. Again, the formula for degree of freedom is shown here. Then using the degree of freedom, we will calculate mean squared variance between the groups and within the groups. And then finally, we'll calculate the F statistic, which is the ratio of between the group mean squared variance and the within the group mean squared variance. So that is how we carry out the one-way Anova test. Then we have two-way Anova test. This is nothing but an extension of one-way Anova test. We use a two-way Anova test when we have one dependent variable and two independent variables. Let's see an example where this test can be used. We will again refer to our earlier example of athletes. So we had a group of athletes and they were divided into three groups: amateur, mid-level and professionals. Now this time we also have their dietary habits. Let's say vegetarian or non-vegetarian. So now based on these inputs, we want to measure their strength levels. So here we can use two-way Anova test. The strength level is our dependent variable and we have two independent variables, that is type of athlete and their dietary habits. Again, the procedure remains the same. We will calculate the F statistic using a software package and then follow the remaining steps which are shown here at the top of the screen. So that is how you conduct two-way Anova testing. Then the last test is Manova. Now Manova is just like an Anova test, but it has several dependent variables. So we will go back to our athlete example again. Here we have three levels of athletes and their dietary habits. But this time we want to compare two dependent variables instead of one. So we will measure strength level as well as their annual income. So in such cases, when we have more than one dependent variables, we can use Manova test. Again, the procedure remains the same. We will first calculate the F statistic and then follow the rest of the steps. So that is how you conduct Manova test. Now there are other hypothesis tests as well, but they are beyond the scope of this module and are not required at this point.